Good afternoon, everyone. We're going to get started in a few more minutes. We're still waiting for a few folks to get registered on the webinar, so stay tuned, and we'll try to get started on time. And so hang tight for a few more minutes. Thank you. All right, everyone, we're at the top of the hour, so we want to be respectful of everybody's time. Good afternoon, and thank you for joining us today for the webinar on effective root control. We appreciate you taking time out of your busy day to be with us today. I'm pleased to introduce Mike Hogan, former CEO of Dukes and a current advisor to the company. Mike is widely recognized as one of the leaders who helped build and grow the modern root control business, shaping many of the practices and long-term strategies that utilities rely on today. Mike's been deeply engaged in the industry throughout his career. He's been a member of NASCO since 1988, served on the board of directors, and was president of the association in 2002, and has also served on the board of NASTI. Mike's going to be joined today by Brian Conroy, Duke's Western Region Sales Manager, who has over 40 years of experience in our industry. Brian's a licensed Oklahoma wastewater operator and an active trainer for the Oklahoma DEQ. He's involved with Oklahoma and Missouri Rural Water Associations and previously served on the Oklahoma Water Pollution Control Association board. Between Mike and Brian, they have over 80 years of experience. And today they're going to share with you proven, field-tested insights into the causes and consequences of root infiltration, discuss treatment approaches, and outline best practices for long-term success. Want to review a couple of housekeeping items? Mike's going to get us kicked off. Brian's going to join us a little later in the presentation, and I'm going to wrap things up. We encourage you to submit questions using the Zoom Q&A feature throughout the session. We'll address these questions at the end of the presentation. And if time permits, we'll also provide an opportunity if you want to ask a question live by raising your hand in Zoom, and then we'll unmute your mic. Thank you again for joining us today. Please join me in welcoming Mike and Brian. Mike?
Well, Mark, thank you very much for that nice introduction. I hear you talk like that, and I think for the first time in my life, I feel old. But I will say Brian is my senior in the Duke's Root Control organization. Brian is the one employee that's got more tenure than me, and I'm very happy to be here today with him participating in this webinar. And additionally, I'd like to thank you and the marketing team here at Dukes who helped put this together. Backstage, we've got Caitlin and Ben who have been very helpful in bringing me up to speed on modern day technology. And in that, I just want to say my first presentation of root control was done in 1988 in North Carolina, or excuse me, Savannah, Georgia, at a 3-day conference that was a Wednesday, Thursday, Friday. And I was volunteered to give a root control presentation at 3 o'clock on Friday afternoon. And as you can imagine, it was an empty room. And I had, I think, 2 folks attended that day. It was my first ever presentation. I was nervous then. And I got to say, I've come full circle because today is my first webinar that I've ever presented. And I'm happy to do it. And hopefully we can share some insights for those attending. I appreciate you taking the time to give you some ideas and concepts that we hope will help you to maintain your wastewater collection system. The objective would be to educate both new and existing clients while implementing a chemical root control program as part of a comprehensive preventive maintenance. Your overall preventive maintenance program can ensure the elimination of collection system root-related problems permanently guaranteed. And that's twice that I've highlighted permanently and guaranteed. And not to imply that Dukes has a silver bullet or a magic wand that will just eliminate your root problems tomorrow. I assure you and promise you that if we had developed that technology and had it available to us, I would probably be on a yacht in the French Riviera right now, enjoying the sunshine. But we've got the best alternative available in today's modern collection system practices. And when abided by and followed, this program can eliminate roots permanently, and Dukes will guarantee that. A comprehensive program is designed to eliminate overflows and blockages and increase collection system capacity through a scheduled proactive program. By focusing on prevention today, we eliminate the need for costly emergency maintenance and extensive rehabilitation tomorrow. Real simple, we change the oil in our automobiles to prevent the engines from failing. Prevention in a sewer system is no different. We take care of it. We prevent problems before they become expensive emergencies down the line. It's the same concept, and we must practice it. Unfortunately, out of sight, out of mind, we often don't get that benefit from our supporting councils and councilmen, but we must strive to find a preventative maintenance program in order to be successful. Just some historical context on Dukes. Dukes has been around since 1948, started by Mr. Alec Duke, who was an immigrant from England after World War II. He started up a plumbing business and a sewer service business. We were one of the first companies to utilize jet trucks. We were one of the first companies to get into CCTV inspection. And Mr. Duke had three sons, and his youngest, Kevin, came out of college in '79, had grown up in the business, and decided with his Cornell World Lit degree that he wanted to specialize in sewer line root control. And he, with his childhood best friend, started the company then. And since that time period, we've provided chemical root control services to over 3,200 municipalities nationwide. Nationwide mean we've covered 47 states up to date. And as of May 1st of this year, we've completed over 456 million feet of sewer line chemical root control. And those that speak in miles terms, that's 86,000 plus miles. And a last little tidbit is that's enough miles to get around the earth 3.5 times. So the point of that is to just demonstrate how experienced Dukes is as an organization in dealing with roots and sewers. All of us are governed or regulated by the EPA and what we do and how we manage our collection systems. And at about the same time Kevin was coming out of school in the late 70s, the EPA came out with a statement in a Brown and Caldwell instructional program that the intrusion of roots into sewers is probably the most destructive single element that faces those maintaining a wastewater collection system. And I key here on the word destructive. I've used this slide since 1988. And when I say that, often folks in the audience will say, yeah, but I experience more grease problems. And you may day to day experience more grease problems than roots. But the key word here being destructive. Roots are alive and growing. And if they're not dealt with, that growth is what ultimately leads to the failure of your collection, your sewer pipe, your collection system. So, and it's also at that point the most expensive part of the problem. So the key word here is destructive. You have two responsibilities maintaining a wastewater collection system if that's your role. Your job is to, one, keep the sewage in the flow, and two, maximize the life of the sewer system. Those are the two most important characteristics of your responsibilities as a collection system manager, employee, engineer, whatever your responsibilities are. EPA got involved mostly back in 1971 with the Clean Water Act, which those of us old enough on this presentation remember there were rivers on fire in this country due to pollution. And the EPA knew then that they had to do something, and the Clean Water Act of 71 was the start of that. Since then, we've had a lot of different programs from the EPA and at the state level. Probably the most successful one, although never implemented as a law, is a CMOM program, which stands for Capacity Management, Operations, and Maintenance of the 16,000 plus collection systems in this country. It was designed and implemented, or I should say, created by a gentleman named Roy Herwig, who was an engineer in the Southeast working for Region 4 of the EPA. And just he recognized there were multiple municipalities within his jurisdiction that were doing an excellent job at maintaining their wastewater collection systems. He dove into and tried to discover why there was a difference, and ultimately it came down to preventive maintenance. So he, at that point, started this program in the Southeast Region 4. It's now spread across the country. And the point is you need to maintenance. If you don't, there needs to be consequences. A lot of states, a lot of organizations have come up with procedures that you must follow. How often you clean your system, how often you TV it, how often you inspect siphons and aerial crossings, off-road easements. So there's a lot in the CMOM program that just designate what we must do. And cleaning pipe, and that means getting the roots out of it, is a big part of that. The collection systems that I mentioned represent about 800,000 miles of sewer pipe in the country today, 500,000 miles of private lateral sewers that connect to our mains and public sewer. So they contribute to what goes on in our main lines. This represents trillions of dollars that is invested in our underground infrastructure. It is, if not the most valuable asset that any municipality has, it is very close to the top. I can't think of anything that would be more valuable than our underground infrastructure. Today, unfortunately, the shortfall on the funds necessary to just bring our systems up to standard is a huge shortfall. The rehabilitation needs are in the hundreds of billions of dollars, and those monies aren't just going to all of a sudden appear for us to take care of it. So you, as a collection system manager, are looking for ways to be more proactive, to be preventive, to maximize the life of your sewer system until those dollars are available to you. So the hundreds of billions aren't coming, but there are methods in place today that can help you cover that in a bridge to get us to that point where we do have the funds available to us. And mostly, the CMOM program addresses the 75,000 sanitary overflows that we experience annually in this country. And I'm going to kind of touch on that a little bit on this next slide. And the reason why the SSOs are what the EPA and the state associations are really going after is when we have an overflow, it's a threat to our nation's public waterways and our public health. And again, prior to the 70s, our rivers and streams in this country were in dire straits, and we've reversed that. And it's because of these programs. But SSOs still happen at a rate of 75,000 a year. And the causes for them are 43% of them are caused by blockages. Blockages that like this slide here, we're showing roots blocking the line. We've got 27% infiltration and inflow, groundwater infiltrating and rainwater infiltrating surface water, causing stoppages. They've got power structural failures of the pipe, where the pipe is collapsed and failed like this one. Ultimately, it may cave in and cause a blockage or an SSO. The others are power failures and some others, but we're going to key in on the 43% by blockages, and that's primarily roots and grease. Debris and collapsed pipe are a part of it, but mostly it's the grease and the roots. And this is by surveys done by the EPA. Again, here we've got a massive blockage, and this blockage is built up of roots, grease, debris, everything that's collected on it. Flow's still able to get around it, but ultimately that won't be the case. We've got collapsed pipe here to the right, and down below here we're just showing how much these roots can grow once they're inside our sewers. We'll get into that a little bit more later as well. So getting into the basic of roots, we need to kind of understand what's happening here. The purpose of the root system is to seek nutrients and anchor the tree. And roots grow at a cellular level at this very tip, this root cap here, which is microscopic at this point. It's the size of a cell. And a little further back, it gets to be the size of a hair. And due to that, it's able to penetrate the smallest of cracks or holes or openings that are in our sewer pipes underground. They grow to your sewers. Well, we've got a development that's put in. We've got infrastructure that's placed in the ground. Then we've got homes that are built, and then we landscape them. And similar to this older neighborhood, you've got this large silver maple tree that the roots are growing down. And as I said, it's first, it's an anchor, and two, it's seeking nutrients and moistures. But how they're growing down to the sewers, it's not what a lot of people think. A lot of people think sewer roots are attracted to the sewage inside the pipe. And no, roots aren't that smart. But what they are attracted to is the moisture, the condensation that forms on the outside of a pipe. You've got a pipe running through the ground with warmer water flowing through it. We get this creation of condensation. If you've ever dug up a pipe, it's always wet and moist around the pipe. And as that moisture evaporates, little microscopic bubbles work their way to the surface here. And that hair root, that cap that I talked about, that's seeking the moisture, finds that vapor trail, grows down here to our sewer pipe. And if this pipe were structurally sound and there weren't a point where these roots could enter, it would just grow along the outside and would not be a problem to us. But unfortunately, the older clay pipes, the concrete pipes that we put in this ground 75 years ago, 50 years ago, even 100 years ago in some cases, the joint materials haven't stood to the test of time. They've broken, they've weakened, and roots are able to penetrate. Just also, too, think about this. I introduced the idea of an anchor. Well, of course, the root is the anchor to the tree. And if we get a heavy windstorm or high wind situation, you're going to have this tree swaying. And when this tree sways, these roots move. When these roots move, they pull on this pipe, and that in itself can create openings for the roots to get into. So again, it's not what's in the pipe that's attractive to it initially, it's what's on the outside, but they always do seem to find their way to our sewer pipes. Why is it an ideal environment? Why do the roots thrive there? Well, we've got an unlimited water supply. We've got an excellent source of nutrients. Our sludges are made up of all these different minerals on the right here. And the 10-10-10, I used to present to people that if you went to the ag store, or the farm store, and bought fertilizer called 10-10-10, it's 10 parts nitrogen, phosphate, and potassium. They sell this stuff in bags of fertilizer. So our sewers are very fertile environments for roots to get into. You've got oxygen and you've got unrestricted growing space. So it's the perfect environment for roots to thrive. And as I said, you've got the compacted soils and everything that it works its way down through to get to our pipe. But once it gets in there, you've got this explosive growth that can occur because of all these benefits to the root mass. Some characteristics to understand and some of the consequences of our own actions. In nature, a tree out in the forest gets the nutrients and the water that it needs right here below the tree in this drip line area, and works very well in nature. But in our urban areas, what do? We put impervious surfaces underneath these trees with roads and sidewalks and driveways, robbing the water that would naturally drip into the soil and feed the root system. Water's washed off into other directions, forcing the root to seek more water, the tree to seek more water. So these roots grow out. And additionally, annually, I should say, we go through and we rake up all the leaves and we haul them off to the dump. And it's those leaves that fall in the ground naturally in nature. They decay, the moistures replenish the soil here again below the tree. And when that happens, the tree sustains itself. But we're not allowing that to happen with our practices. So what happens is these roots grow 4 to 7 times the drip line of the tree. And in our situation where we've installed sewers down the middle of the street, we often wonder how roots get all the way out there, but this is why they get there. They're going to actively seek out the nutrients and moisture that they need for survival. Again, it's an unintended consequence of our actions, but we are contributing to the problem. I mentioned out of sight, out of mind earlier. Our councils and boards and those that help us develop our budgets to do proper maintenance, they don't see what goes in on our sewer, but it's a real quick analogy when you see a 4-inch slab sidewalk like this that's been lifted and separated by roots growing underneath it, to just correlate that with our pipes. What's a 3/4 inch pipe to a root when you see what it's doing to this slab? Once the roots get to your sewer pipe and get through it and into it, that growth is still happening at that point of entry, and that's where the destruction has. But whenever a council member, someone talks to me about, "Well, I don't really see what's going on down there," but this is one way to point out to them what is happening. So problems that we know, those of us in collection system maintenance, we know what's happening. Roots are an initial cause of grease and debris buildup. And I say that because here we've got this grade 1 root per the NASCO PACP rating system. This is a grade 1 root, small little hair roots coming through the joint here. Nothing really collecting on them at this point. Obviously not going to prevent any cause any stoppages or blockages. But ultimately, when left alone, what happens is it turns to this grade 5. And this grade 5 is a lot of hair roots that grew across the crown, fell down to the pipe, over time collected a lot of grease and debris, and ultimately becomes a huge blockage potential, which could be an overflow for you. So roots are what I like to call, and I'll give credit to a client of ours named George Kurz out of Chattanooga, Tennessee, back in the 90s. He came up to me and said, "I hear you with the grease and the debris and the problems those cause, but if I didn't have the roots, I wouldn't always have the grease and debris problem." And he's right. And he explained to me, sewers are designed to flow hydraulically at a certain rate to move solids through into the wastewater treatment plant. But when roots grow in the line, slow down the flow, what starts to happen? Debris starts to settle out. As that debris starts to settle out, the flow levels come up. When the flow levels come up, they get in contact with the roots. Roots aren't aquatic. They aren't growing down in the flow line. They're up above it. But as the flows kick up and down with peak time, peak demand, stormwater entry, you are then facilitating, the roots facilitate more grease getting collected. And ultimately it becomes this big blockage. And there's very little root mass there, most probably, but it's a huge potential problem for us. So roots are the first cause for grease and debris buildup, reduction of flow capacity, ultimately leading to the SSOs and the blockages. And as over here on the right, you're seeing this tree illustrating the roots growing down to our pipe. It's got into the joints, and ultimately it will crack and fracture the pipe, as I've mentioned. So what is the role of root control as the foundation of a comprehensive preventive maintenance program? And when I talk about root control, preventive maintenance, and comprehensive preventive maintenance, comprehensive is your overall approach. Root control is just one of the tools necessary to have an effective, comprehensive program. So what are we going to do about these? What have we been doing? What are we going to do? Well, we've had mechanical methods to deal with it. We've got rehabilitation methods to deal with it. And we've got chemical, herbicidal, our particular Duke's method of dealing with roots. So there are options out there. And all of these are important and useful tools if you truly have a comprehensive program. The mechanical methods that we use today, everybody knows that there's rotting machines, bucket machines available to you. These particular pieces of equipment utilize tools like this, what they call a porcupine or an auger bit or a cutter. And they use basically brute force with cable and winch systems to pull these tools through the pipe, grabbing onto the root and tugging basically as hard as they can to rip the roots out. It's effective at removing root masses, but it can also be very destructive to the pipe material. It doesn't take a lot of pressure to pull in a pipe with these kinds of tools. More recently being the last 30, 40 years, most cities are using hydraulic cleaners, jet trucks. And the nozzle technology that's available to us today is exceptional. There are some great nozzle technologies out there that will get that pipe clean. They will cut the roots out. They will pressure wash the roots out, whatever method they're using, spinning chains at high rates of speed, they will clean the roots out. And it's effective at doing that. And you need it because when you have an emergency, if a line were to plug up today after this call, you're going to need to send a piece of equipment out there that can deal with it now, get that pipe open. Chemical root control doesn't do that. Chemical root control is the long-term approach. But the emergency repair that you need these mechanical methods to do that. But the true results of these mechanical methods is it's no different than what the utility company does when they drive out and cut down the trees that are growing up into their power lines. We often see it. You'll see they'll just cut these trees back to nothing. And this is what it looks like shortly after happening. But if you came back in a year, you're going to see multiple new shoots coming out of every one of these cuts. That's the reality. And the reality is it invigorates their regrowth. Cutting them only exacerbates new regrowth. It is one of the consequences of cutting is you're only promoting a bigger problem. And we'll get into that a little bit more. But I've took that photo of that power line tree, inverted it into a simulated pipe here. The concept is no different than what we see every day. In fact, it's what we do in our yards. A lot of us have vegetation in our yards that we trim and manicure to have it look good. And if you notice, every time you cut it, if you look at the base of that bush or that tree that you're trimming, it's getting thicker and larger every time you do it. And that same effect is happening in our pipes with the cutting and pruning that we're doing. Another method for dealing with roots and sewers is rehabilitation. We can dig it and replace it. And here we are on the right showing exactly how we do that. We dig out clay pipe or concrete pipe, put in plastic. It's an excellent way to get rid of roots. Absolutely the most expensive way you could ever deal with a root problem. Very intrusive to your residents and communities. But if it's structurally, if the pipe has failed, this is what you would need to do. That would be a part of your comprehensive program. Replace the line if structurally the pipe has failed. But if all it is a root problem that's in the line, then there's no need to go to this extreme. We can CIPP it, cured in place pipelines. Again, great way to get rid of roots in the lines. You got one continuous sleeve going through a pipe. You eliminate the points of entry through the 4-foot, 5-foot joints that we saw in the clay pipe. Very effective. But it does lead to a problem in that the connections, unless you line those connections 5-10 feet up the services, the roots are going to be right there where the hose pipe was lined and the connections are tied in. And roots are going to still be able to enter at that point. And we have lots of clients that we actually treat cured in place pipe because of roots coming in at the service connections. There's slip lining and pipe bursting available to you as well. Again, it's a way to renew the pipe, but it's not a cost-effective way of dealing with root control, but necessary when the structural integrity has failed. So the unfortunate truth here, that the problems we are dealing with today are the result of the way we have been maintaining our sewers for the past 75 years. We just haven't done the best job available in maintaining our sewers to try to maximize that life. We're often reactive, and we're going to get into that. So the mechanical and rehabilitation methods are difficult. They're destructive, potentially very destructive. They are very expensive and costly, and they're reactive. In all these situations, you're utilizing these pieces of equipment to react to our failure of the past. Or you're reacting to an emergency call, which in that situation, it's necessary. But to just deal with roots with these pieces of equipment, you will not have a successful, comprehensive root control program. So what's another way? And we're here to talk about adding chemical root control to your comprehensive plan. And we're going to show you why it's supported with lots of data demonstrating its effectiveness and why it's proactive versus reactive. Quickly, I'd just like to explain the application process, and it's not complicated, folks. We have a lightweight piece of equipment that we house all of our foam generation equipment, every tool necessary to do lines that are highway, street lines, backyard easements, narrow alleys, you name it. We've often said if we can't get to it, it can't be done because we have the capability also of pulling hoses into backyards. But the process is simple. Crew rolls up on the manhole. We insert this 1 inch plastic water service hose through the entire length of the pipe in almost every case. If we can't get all the way through, it's possible that we can treat from both sides. So we don't only have to go one direction, we can go both ways. And we can treat any pipe from 4 inch house laterals. We can go in at the connections with a little different modification to this piece of equipment and pump foam through the clean out down to the main. But primarily we treat 6 inch to, I'd say 15 to 18 inches, 90% of the 30, 25 million feet we do a year. But we are capable of doing pipe diameters up to 96 inch. We do a lot of 24 outfall, 36 outfall, but we have done up to 96 inch pipe. And we've done it all with this one piece of equipment. So it's very versatile, allows us to get around the country cost effectively and be able to do any job on any city that we pull up for. So, but again, simple process. One thing I didn't mention is this foam is generated mechanically here at the truck. It's not a chemically generated foam that's produced down in the pipe. That way we know exactly the quality of the application and the foam necessary to do its job. And we'll get into that here in just a second. It's important we talk about the herbicides. You know, every city I've ever worked for, a lot of times the first question is it safe for my wastewater treatment plant? And the answer is yes. And I'll get into that why through the chemical description. The products that have been available for maintaining roots and sewers have started back in the 40s and the 50s with acids and solvents, still around, still used, not very much, but here the concept was throw down an acid that's supposedly going to burn the roots out. Second, they came up with copper sulfate, a heavy metal, poisonous to the tree, to the whole tree, by the way. But the idea was to pour copper sulfate tablets down the line, kind of block the flow so that the flow blacks up and drowns the roots. You'll have this copper sulfate residue in there, and it's supposedly going to kill the root. It'll also kill the tree, but the biggest harmful effect is the heavy metals making their way to the treatment plant. So mostly not used. You can buy it at Home Depot if you'd like to do your house line with it, surprisingly, but not used very much in municipal lines these days. Diclofenac was the first herbicide introduced. Diclofenac is a growth inhibitor, not an actual killer. It could be effective when used in conjunction with other products. Rudex is a product that's on the market that utilizes diclofenac mixed with sulfuric acid, sulfamic acid, and the acid generates a chemical reaction and bubbles, and then supposedly gets the diclofenac up into the root. Effective for lateral lines. Hasn't been as successful in the mains, requires repeat applications. The method of application is challenging, but it can be effective when used. Metam sodium was the first what I'll call full strength herbicide, came out in the 70s. It was combined with diclofenac. So you had the big punch of the metam, and then you had the growth inhibitor of the diclofenac. Worked effectively. Used it for a long time ourselves, but in the mid 90s, the EPA came out and classified it as a known carcinogen. And Dukes at that time decided it was in our best interest to get away from it for the safety of our workers. And also it had detrimental effects at the wastewater treatment plant. So we got away from it at that time. And it was then discovered that diquat-dibromide, another herbicide that's been around since the 50s and 60s, was effective at killing roots. And since I think 98 or 99, that is what we're still using today. Because unfortunately, herbicide technology doesn't advance very quickly. There has not been a new herbicide introduced that's available to us since the 60s. So there's nothing that's been developed. But if it does get developed, we hope that Dukes will be the one to bring it to you. So Duke's chemical root control program specifically, what makes us expert? One, I talked about our longevity in the industry. We've been specializing in root control for 47 plus years. And over that time, our techniques have developed to be expert. Our products that we use are expert, and I'm going to go into those. And we're utilizing, as I said, the best herbicide technology available today with diquat-dibromide. We know when applied properly, it's safe for wastewater treatment plants. We do, as I said, millions and millions of feet a year. We have procedures in place that we check with the municipal wastewater treatment plant before any treatments are done. We notify them of our application rates, where we'll be working. We stay in close contact with them to make sure and ensure that there aren't any problems at the wastewater treatment plants. We know that these products will not harm the above ground vegetation. They aren't designed to translocate up and into the tree. They're only going to kill in the small amount of root that they come in contact with in the pipe, and it will only translocate, we're hoping for 5 to 10 inches outside the pipe. That 5 to 10 inches outside the pipe is important. I want to go back here and show you. As this root's growing down, those pieces of mechanical equipment tools that we talked about do an excellent job at removing the roots that are right here in this pipe. But they're not doing anything to these roots outside here. The best operator in the world can get you what I would call a rifle barrel, sewer clean. But the second he drives away, these roots are growing back. He's done nothing to abate future regrowth. The benefit of the herbicide technology that Duke's uses is this foam, as it sits in contact with this root, is killing it in the pipe. And we hope, and it depends on the amount of volume of root that is encasing the pipe, we hope to get 5 to 10 inches outside the pipe on a first application and further than that on a second application. And that in itself is what allows us to guarantee that the lines aren't going to have any backups or stoppages for a period of 2 to 3 years. It's due to the nature of how far outside the pipe we kill these roots. So we haven't hurt the tree. This foam photograph here of the foam is demonstrating to you the quality of the foam. And I know it sounds silly to say, state-of-the-art foam, but if you've ever used cheap shaving cream versus the top line products, there's a big difference in foam quality. That foam quality is very important to us because it's the bubbles in the foam, and then actually it's the space between the bubbles that carries the herbicide up into the top of the pipe and gives us the necessary contact time to kill the roots, which is about an hour. We don't need much more than an hour. Often you'll see this line stand up in a pipe for 24 hours and sometimes more. Eventually it'll dissipate, return to fluid. The fluid will enter into the flow. The flow goes to the treatment plant. As I said, we've already notified them. They know what to expect and will have no harmful effects at the treatment plant. Roots aren't aquatic. As I mentioned, they aren't growing down here. If this were flow in this pipe, it'd be at about this level. If you're using any type of pour down products, you're not getting up here, which is where the roots are, which is why these foaming technologies are so important. Additionally, we incorporate emulsifiers, degreasers into the foaming agent so that we do strip off those grease and debris muck buildup that I showed you earlier. We get that off of the roots so that we can get more absorption of our herbicide up into the root. So it's a combination of all these that make that effective. The application process, we do not have to interrupt service. We're not bypassing, we're not blocking. If we have any situation that prevents us from treating it, our preference is to come back at off-peak, whatever that is. And we'll treat lines at off-peak to get the necessary contact time we need. The big differentiator with Duke's is the quality of our applicators. Our applicators, as you know, have millions and millions of feet of experience, which is important on knowing how to do the job in the application correctly. But it's also important because we are handling pesticides. We are in high traffic situations. We are sometimes dealing with sensitive treatment plants, small treatment plants even. In those scenarios, it's important that our applicators know exactly what to do and what not to do to make sure that there's no liability for you, the municipality, or us as the applicator. And lastly, I mentioned that Duke's offers a 2 to 3 year warranty against stoppages on any lines we treat. Again, indicative of how far outside the pipe we get. But when you instill a program, a chemical root control program that kills the roots today, kills them outside the pipe, and then you maintain that program every 3 years, we can eliminate roots permanently and guaranteed. And I'm going to show you that in some of these results. What you can expect if you bring Duke's in to help you with a root control problem, expectations are these. We know through tracking every line we've ever treated and what percentage we get a callback on, we know that we're going to be 90 to 99% effective on a first time treatment. And if you apply a second time 2 years later, then you know at that point we're going to guarantee it for 3 years. And the reason we increase from 2 to 3 is because that second treatment, we're getting much further translocation outside the pipe, therefore preventing new growth from coming back in as fast as it would with other methods. We know we can go even further outside and therefore guarantee it for 3 years. And our success rate on second applications gets into the 95 to 99%. I don't ever want to say 100, but most of our customers experience that type of level of success at 100%. What that does for you, if we're reducing all these root-related problems, it's going to reduce your need to send out crews to deal with them. And often we're dealing with these stoppages on evenings and weekends and holidays, and you will see a reduction in overtime expenses if that's your priority. We're going to significantly increase the effectiveness of your in-house work, your in-house scheduled maintenance. You guys have lots of equipment designed to go out and clean the grease spots or the hot spots, we may call them. And if we're dealing with your root problems for you, and we can reduce you having to send crews out to maintenance or cut or clean out root-related problems, imagine the resources that'll free up for you, the equipment and the time available for you to do more cost-effective things that you do in-house when we're focusing on your roots for you. We will increase capacity. If you get all those root muck joint globs out of your pipe, those big blockages, if you get them out of your system, you will reclaim your capacity. Your flow will move as it's designed to move. The debris will move its way to the treatment plant instead of settling out in your lines. You will see increased capacity when chemical root control is initiated into your program. And last and most importantly, I've talked about it, you got two responsibilities: keep it in the sewer and preserve the life of the pipe. And we know for fact that when you utilize chemical root control that gets outside the pipe and kills those roots, the structural integrity of that pipe will be sound from the day we initially treat it and for as long as you keep and maintain your root control program going, giving you future sustainability of your whole system. The most cost-effective thing you can do for your municipality is to save that pipe, maximize the life of that pipe. Couple simple case studies. I've got a city that I was involved with in the Carolinas and 35 years ago that I went in to meet. They had lines scheduled to be dug up and replaced because of roots. I said, before you do that, just give me one shot. Let me treat these lines for you and let's see what happens. And I can tell you 35 years later, those lines are still in service, still operating. The structural integrity hasn't decreased one bit from 35 years ago. That's what I'm talking about when I mentioned we can save your pipe. Imagine what that dig up project could have cost them. Back then, I think we were charging $1.29 a foot for root control. They got a lot of years of treatment by not having to dig up that pipe. Another city in the Midwest, we've been treating since the early 2000s. They've deemed it one of their most important maintenance items, resulting in a huge reduction of their SSOs, their data showing a 99% success rate. And it's allowed them, as I kind of mentioned earlier, to systematically plan to get around their system. Some people call it turn their system, maintenance. You may be required to clean it every 7 years, TV it every 10 years, or vice versa. But it's helped them to be more efficient at doing what they need to do while we're handling their root problem for them. And lastly, this is kind of an interesting one. In Oklahoma, there's an insurance organization that insures the cities in the event that sewage backs up into a home. And they recognized that a lot of their clients weren't having the problems, looked into it, similar to the CMOM approach, and saw that the clients that were utilizing us for root control weren't having the backups. And as a result, the agency, OMAG, went out and offered a $1-to-$1 match to municipalities in Oklahoma when they spend money on Duke's Root Control's chemical program. they will match and give them the equivalent dollars to increase the amount of footage they do. So it says a lot. And I would tell you, if I were sitting in your office, it's a line I've used since the beginning of my career. If I were sitting in your office, I would offer to wallpaper your office with references. If you need more information, we will get it to you. We will give you cities nearby you that can validate these results and talk to you about how their program's been successful and help you understand how best to implement it. So we'll get into implementation here in a second with Brian, but I want to close my portion of this presentation by one of the things that makes me proudest as being a part of this organization for as long as I have is that 95% of our clients maintain their program year over year, proving that a partnership with Dukes to solve root-related problem meets and exceeds all their expectations. And that says it all to me in this industry. When you're good at what you do and you're a good contractor and you provide good service, but most importantly, you show results, we love the fact that our clients keep bringing us back year after year. And the stories that I mentioned in the case studies, we've got, hundreds and hundreds of those, thousands of those we can share with you. So ask around when you're at a state association meeting, ask other cities what they're doing. We've worked for a lot of municipalities. We hope they can help you, but if they can't, we've got couple dozen sales representatives across the country that would love to meet with you and share our expertise with you. So at that point, I'm going to turn it over to Brian and let Brian talk to you about how to implement the root control program. Brian, it's all yours.
Well, great job, Mike. Fantastic job of explaining to people the importance of maintaining their root issues in their sewer pipes. Ignoring them it's just not worth it. There's too many issues are going to happen, and it is an integral part of an asset management program. And I thought you did a great job of highlighting the fact that it is an integral part. So I get to do the fun part and talk about implementing a chemical root control program. You've got roots in your sewer system. You're tired of the historical methods of maybe cutting those roots out, or you don't have the money to replace these pipes. And so how are you going to attack it? And it's very easy to start a chemical root control program. Any one of the representatives at Dukes can come by and help you organize the information you need to start a program. Many of the things that we're going to recommend that you look at is certainly your pipe material. Clay and concrete pipe are notorious for allowing roots to get into them. The age of your sewer system, obviously. We have found that most sewers that are at least 35 years old or older are susceptible to roots getting inside of them. Of course, if your pipes are running through wooded easements, through the woods, along creeks, where there are numerous trees, the pipes are a source for those roots to get into. Sewer lines with numerous laterals. Many of our clients suffer not only the root problem of the roots getting inside the joints, but they're growing down the laterals and into the mains. And of course, when we treat a sewer pipe, we're not just killing the roots in the pipe or getting it outside the pipe through the joints, but we're also able to pump that foam up the lateral 5 to 10 feet, offering a tremendous benefit to the maintenance department, but also to the homeowners. And then, of course, you can use your historical data. You probably have a list of lines that you're maintaining on a regular basis, sort of your hot shot list that you're doing every 30, 60, or 90 days. You've got your CCTV and cleaning list. Perhaps you're doing television work on a regular basis or using contractors. All of those are sources of information that you can use. And then we recommend you plot it onto your GIS system. So if you're utilizing GIS, you could share your shapefile information with us. We can plot it on our project platform, and we can actually put all that data on the map for you as well. And now you can have a visual appearance of where your root problems are in your collection system and make a targeted approach at how you can do that, how you can budget the right amount of money to attack your problem in a way that you can afford. And if still there are many of our clients that don't utilize GIS, they're still using paper maps, but it is important to plot that information on some type of mapping program so the work can be done effectively and efficiently. And of course, that's one of the tremendous benefits of utilizing Dukes. If you could go back one slide, please. Is maintaining records of the treatments. So if you're going to be managing a program like chemical root control, it's going to be a multi-year program. You're going to want to get onto a 3-year cycle. And again, one of the benefits of partnering with Dukes is we take it on to be the managers of that program for you. We're going to keep track of where you've been treating your pipes. We're going to meet with you once a year, present to you your annual chemical root control program report. It consists of both a statistical overview of the success of your program. In fact, Mike did a great job of pointing out success rate. At our last business meeting that we had in December, our company leadership announced that 99.6% of the pipes that we treated in the history of Dukes have not plugged up under guarantee due to roots. And so we do that statistical success rate for each and every individual client when we meet with you at least once a year to go over it. The other part of that program report is a list of all the sewer lines that we've treated, what the status is of them. Have you had any problems? Do we need to provide you a retreatment because you did have a problem? And we help you plan what you need to be treating in the future as far as repeat treatments or any new sewer lines that you found that have roots that need to be incorporated. We call that BlackBerry report. You might be referred to that when our sales reps talk to you. We call it a BlackBerry report because it's where my computer wants to update, of course. Excuse me. So we call it a BlackBerry report because really that low-hanging fruit, the line segments in your sewer system that have roots, they're the easiest problems and stoppages and SSOs to reduce when you partner with Dukes to do your chemical root control program. So offering that management of all of the data that's collected, when pipes are treated, when they need to be treated again, and what your costs are going to be for your next budget is all something that we can help you in your program management. And then, of course, one of the great things about being part of an asset management program is that we can show you a return on investment through your chemical root control program. Keeping, as Mike mentioned, keeping the flow in the pipe in the ground for as long as possible for the least amount of budget, and at the same time meeting your compliance and customer service goals. On top of that, we can show you how to save money doing it. So we can do this, what we call ROI calculator, with every individual client, utilizing your own internal data to help you compare the cost of doing chemical root control as to doing it with CCTV and cleaning. And just to give you a rough outline of what those costs might look like, on average, when you're treating a sewer line with the Dukes root control program, it costs about 65 cents per foot on an annual basis to manage your root program. Whereas compared to national average costs of $2 a foot annually to do chemical or to do CCTV and cleaning, it's a no-brainer. It's almost 3 times less expensive to do chemical root control to manage your root issues rather than doing the traditional method of cleaning and TVing. And so we'd like the capability to do that with you. If you're interested, you can use the ROI calculator QR code here. It'll take you to that site where you can do it yourself. But we'd love to come by and talk to you about what your current in-house costs are now to do it and compare it to how you can control and save funds using the Dukes program.
Awesome. Thank you, Brian.
You're welcome.
And I'll just add in what Brian alluded to. If you go to that site, what you're going to do is you're going to be able to see some examples of a small, medium, and large collection system as far as what their ROI is. And if you want to get more detailed, you can once again, as Brian said, get in touch with our sales folks, and they'll go through one with you using your numbers. But that'll be a commitment on your behalf. But the examples are there for you to take a look at. And once again, Brian, thanks for sharing that. I want to wrap up before we get to Q&A to make sure, although most of what we talked about today was associated with with root control. We also provide services for us that also can help you with other projects, be that CCTV and cleaning, helping you find I&I in the form of doing micro detection, flow monitoring, also pump station monitoring, and then any assistance you need with potential acoustics inspection, smoke and dye testing, and also any projects you have for manhole inspections, and then also additional capabilities for helping you locate and inspect potential crossbores, and then a non-invasive price for doing non-evasive way of doing say that real fast, excavation. Okay. So we have other services. Once again, reach out to us and we can talk about it. And with that, what I would like to do is go through some of the questions. Let me start with the first question, Brian and Mike. What's the best timing for herbicide application? Is effectiveness reduced if timing is too early in the spring before bud break?
Brian, I can take that one.
Go for it.
Well, there was a study done by Furman University back in the 70s that wanted to determine exactly that. And what was discovered was that there's no difference in the growth underground during the dormant times of the years. It was so minuscule, the difference in the translocation of the products, that it was determined by that particular client who had that concern, when should we best do our treatments? And it made no difference. And we've proven that over our 47 years. We've worked across the country. Inevitably, it seems like we're in Maine in January and Florida in August. So, and no detrimental effects as a result of treating in the winter. So the herbicides will still do what they need to do to kill the roots in the sewer, even when the tree is dormant.
Thanks, Mike. Next question, and I'll probably do maybe two more and then I'm going to wrap up because I want to keep people on time. How long does it typically take for utility to see meaningful results after starting a comprehensive root control program?
Brian?
Yeah, I'd like to tackle that one. So once the root control product's been applied, the roots start to die immediately. We're using a contact herbicide, which simply means it starts to work as soon as it makes contact. Within 24 hours, the roots are dead. So you have a pipe full of dead roots essentially the next day. But it does take time for the roots to rot and decompose. Typical results are somewhere around 90 to 120 days. The roots are rotted enough that they'll start to slough off on their own. At least they'll be brittle and weak enough that they're no longer able to support a stoppage. So you might actually get some buildup of flow behind a dead root mass, but it simply can't support it. It'll break off and the roots will fall downstream. This is actually a good time for you to schedule a follow-up evaluation with the sales rep that's working with you in your part of the country. Especially for all of our first-time clients, we like to come back within that 4 to 5 month period after the first treatment and help you go through a small evaluation process of actually seeing what those dead roots look like. And then you get to measure for yourself the success of the product without waiting 2 or 3 years to see if you get a stoppage or not.
Thanks, Brian.
Yep.
One of the other questions is, will I be able to get access to this presentation and listen to it again? The answer to that is yes. We will be sending out to you and a follow-up associated with this webinar to provide you with a link to be able to review this again, as well as some follow-up on any potential projects you may have underway. I did want to close with also making sure that you're aware that if you want to apply for any CEU credit, that please scan this QR code, enter the information, and we'll provide you with a certificate of completion if you choose to be able to submit that or want to submit that for any credit to your respective agency. With that, I want to thank Mike. I want to thank Brian for sharing that wisdom of 80 years and that experience. that they have, and also want to thank Caitlin and Ben as far as coordinating in the background, as far as all the things that it took to pull off this webinar. And once again, want to thank all of you for taking time out of your day. If you have any questions, on the screen right there is an email you can reach out to, but we will also be providing you with information as follow-up on the webinar today. And want to thank you once again and wish you a great day.
Thanks, everybody.
Thanks, everybody.
Thanks, everybody.
Appreciate the time. Is it closed up, Mark?
We still have a few more folks on, so they're closing it up. I don't know if people are hanging on or they just happen to have it still going and they just didn't know how to disconnect.
I'm going to go ahead and drop out.
Yeah, let's connect back up, Mike. I'll
Yeah,
get
come.
all right.
Yep.
Okay.
Thanks.
Bye.